Of the three-digit positive integers whose three digits are all different and at non-zero, how many are odd integers greater than 700? So we have a lot of restrictions here, right? We got our digits have to be all different. They got to be non-zero. They have to be odd, and our number has to be greater than 700. Uh, so how should we do this? So you could probably just start writing out uh, a few examples, maybe the first few examples, and sort of look for patterns and then extrapolate from there. And hopefully uh, you won't have to count every single number. You can find some pattern um, and only count a few and figure it out. Or you can think of it more like a combination question. So let's see if we can do that. But here you got to be a little bit careful, it looks like. So say our number is ABC. So ABC are our digits. And we know that if our number, it has to be greater than 700. So our options for our hundreds digit are 7, 8, and 9. Our middle digit can be anything as long as it's non-zero. So that's 1 through 9 are our options. And then for our ones digit, our number has to be odd. So that means our ones digit has to be odd. So it can only be 1, 3, 5, 7, or 9. So if we then talk about, okay, what are the number of possibilities for each slot, we cannot say something like, okay, I have 5 possibilities here, 9 here, and 3 here, because we have to, there are dependencies going on here, meaning how many options, if I choose a 7 to be in this slot, how many options do I have for C? Well, you'd only have 4, right? Because we can't reuse the 7. But if I choose 8 to be in my 100 spot, well, now I can use any of my options for C. So we have to take this into account somehow. And so I would say let's continue doing sort of what we just did there. In other words, let's find the number of combinations given each of the possibilities, say for our hundreds digit A. So if I choose, if I put 7 there, or if I put 8 there, or if I put 9 there, how many possibilities do I have for the remainder of my slots? And so how many options do I have for A in each of these cases? Well, that's always going to be 1, right? Because we are predetermining what that number is. We're saying that's 7 here, that's 8 here, and that's 9 here. Now, so if A is equal to 7, we have 4 options for what C could be. Now, B can be any number 1 through 9, but it can't be whatever numbers we chose for A or C. So there's really only 7 options here, and that looks like it's going to be true for all of our cases. So let's go to A is equal to 8 now. So if A is equal to 8, we got 1 option for what can be A. Now we can use all of our options for C, right? So we got 5 options there. And still we got to just subtract 2 from our 9 options for B. So we get 7. This will also be 7. So now if A is equal to 9, we can only use 4 of our options for C because we can't use the 9 again. And so that will be the same number that we get here. So here total, we got 28 options. If A is equal to 7, we got 35 options. If A is equal to 8, and we got 28 options. If A is equal to 9. And so if we sum these up, we get 56 plus 35, which is 91, which is B. Fun question. Hard, but fun.